Are you able to hear me? Hello. Just so I hope you are very clear with the construct of the model definition, the features and labels. Okay. Features always define what? Your inputs, and your labels always define your outputs. Am I clear? Now, if you are a core computer science graduate, I don't think you have any fundamental confusion on the definition of algorithm. Now, the basic idea behind the algorithm is same, but the constructive state with respect to your AI and ML in approach, you should understand the difference. Be very, very clear about it. You know that according to the computer science environment, algorithm is nothing but a set of instructions that are defined in a systematic procedure. So here also you should understand an algorithm is a systematic procedure or any kind of formula that is fundamentally having one direct goal. The goal is to train the machine learning model. So here, any kind of algorithm we are designing that algorithm only for the purpose of training the machine learning model. Am I clear? So, in which way, if you are training your machine learning model, it can give you the correct predictions. That will be the target for any kind of algorithm you are implementing here. Therefore, if you take the definition of the core computer sciences algorithm and you come into the machine learning constructs, you'll have confusions. Be very clear about that. So what is that systematic procedure you are trying to research, or you're trying to identify the formula that can make your machine learning model get trained in such a way that with every time it is getting trained, it is trying to give you a better prediction, making you move towards your target goal. So all machine learning algorithms, they should have the ability to guide the process of learning from the input data, whatever we are supplying, and they should build the consistent, accurate machine learning models. So whatever kind of input data we supply means what? Features. Your algorithm should guide the process to build a consistent, accurate machine learning model in a span of a time. Now, how much time it will take for building an accurate machine learning model by applying through the rule of the algorithm depends on the complexity of the domain and the level of accuracy what you're expecting in the domain. Am I clear? It can happen in one day, it can happen in 1 year, it can happen in 50 years, man. It depends on the area of your fundamental application. So you should always understand your entire machine learning models are totally driven. They are driving forces, or they are totally driven by your algorithms only. Therefore, your algorithm is the actual driving force that fundamentally enables the model to learn patterns from the data. From the data, whatever you are supplying, or the features, whatever you're supplying, it is your algorithm that drives the model to learn and go to the next level of the intelligence that is expected with respect to your accuracy levels. So if you are not building a proper algorithm can you expect a machine learning model to really learn for correct predictions from the patterns of the data? No. Now remember, you cannot take algorithm as simple as what you take it in your computer science environments when you come to the machine learning models. Be very clear. So the target of any machine learning algorithm is to make the model to get trained very properly, identifying the different kinds of patterns that are getting generated as the model is pushed with the data. So every algorithm you're designing, that algorithm actually determines how the machine learning model is getting trained, it is getting optimized, and it is getting evaluated. There are three targets with which any machine learning model algorithm should work. The first target is to see that it is making the environment to get trained. As it is getting trained, evaluate and check it is reaching the expected optimization of the accuracy or not. So you need to always understand these particular factors very clearly. Are you getting me? So you need to understand the algorithmic nuances, which is very, very crucial for building effective machine learning models. Means you applied some linear regression, you're about to achieve 70% of the accuracy, but your client's demand is say like 90% accuracy. Now you did some 1,000 trainings, okay? By supplying the new data, you're technically trying to supply the new features, and then you're running through the algorithm once again. But after 1,000 different epochs you have implemented with the new data that is being pushed every time through the process, you are basically able to achieve only up to 75% accuracy. Then you should definitely try to understand the nuances of your particular algorithm, where exactly algorithm is not fitting to the rule of the accuracy that you're expecting. If it is not fitting, do you have the ability of making any kind of research level implementations to change certain standards of the algorithm, or shall we take the support of some other algorithm for the remaining part of the 15 to 20% accuracy that is expected? Your data is wrong, or your number of iterations are wrong, or your pattern, what you're defining is wrong, maybe your features, what you're supplying are wrong. So many number of things you have to concentrate and cross-verify, and then see that effectively your algorithm can build the accuracy of the model. So you cannot directly take one single reason for the purpose. Are you getting me? People always think that if the amount of data is increased, then the accuracy will increase. May not be. If the number of times the experiment is conducted, then technically the rule of the accuracy increases, may or may not be. Means in machine learning models, whenever you're defining the algorithms, you can't just expect only one specific area to be an influencing factor for building the effective machine learning model. Therefore, you need to understand different constructs of the algorithm definitely, and formally you should set a mathematical instruction or rules that is that basically makes a machine learning model to follow to identify patterns and relationships in the data. So algorithm here is not just for sake of implementing the formula with the straightforward values. So what are those set of mathematical instructions or rules that your machine learning model should follow, technically identifying the patterns, and once it identifies the patterns, understands the relationships in the data. Means which a particular feature is influencing more on your prediction, which a particular feature is influencing less on your particular prediction. You should have clarity, and you should be in a position to give that fact of intelligence to your construct of your algorithm. Am I clear? It can be overfitting, it can be underfitting also. You can't say, Suresh, how you can say that? Learning can even make you underfit. I've seen many times in interviews, getting students' resumes containing different number of technologies. And we ask a basic question, he doesn't answer. We ask him, your resume looks so hi-fi, but you're unable to catch up with the basic. He simply says, so with so many technologies, I got confused. Means underfitting can happen. No, he learned so many things. He lost the common sense of the basics. So don't think that it is always overfitting only. It can be overfitting, it can be underfitting also. Okay. You give unwanted features and you're keeping the algorithm in learning, you will get only underfitting accuracy. Yes or no? You're given the correct features, but you did not have the ability to understand the relationship between those features very properly by their state of priority. Then underfitting can take place. So you're more of common sense and subject level intelligence integrated with your domain level constructive relations is very important. Am I clear? That's where you take the computer science algorithm as a definition, and if you come into the machine learning environments, you'll get confused. So you need to remember algorithm as the basic processes of what? Algorithm as basic process of input data. Man. Now, I think normal computer science algorithm also has the input data. But when you come to the machine learning environment, this input data is what? Features. Are you getting me? So are you not, if you're not giving correct features to the correct situation of your analysis, don't you think that the algorithm can misbehave? Now, can you expect two different kinds of predictive level projects you're trying to do in the same domain? They will definitely expect the same features. No, definitely not. Be very, very clear about that. The second thing is makes decisions and predictions. Your algorithm should have the ability of making decisions and predictions, not just calculations. In general, computer science algorithms, we are concentrating and focusing on what? Calculations. Yes or no? But here we need to think about the construct of the decisions and predictions. Now, once your predictive levels are not looking exactly to the expected level of accuracy, then we need to think of iterations. Means how many number of times you should conduct the experiment by supplying the corresponding features to refine itself to minimize the error and improve the accuracy. So with what kind of constructive changes, if you try to refine the features and your decisions and predictions logic, you can minimize the error and finally you can improve the accuracy and get your target goal of the value. Taking through the computer science environment, and if you're making the constructive discussions, it's not your algorithmic responsibilities with respect to your machine learning constructs are looking something different, man. This fact, if you're not clear and you're just saying that I'm a computer science graduate, it doesn't matter here. That's the reason everybody, including core software engineers to application developers, support and maintenance specialists, administrators, everybody, if they want to come into AI ML, they should first change their state of the thought process as per the machine learning requirement with every terminology what we speak. So in machine learning, selection and suitability of algorithm plays a very, very vital role, man. Now, please be very clear, especially for people keeping experience, saying that they have done with one or two AI projects. I'm telling you, if you come and say, I have done this with linear regression, you gave some problem, man, and that problem you are saying that you have done with linear regression. If a proper machine learning expert is sitting in front of you, trust me, he will never ask you what is linear regression. The question will be, can you tell me for this particular problem, why did you select linear regression, and explain me the suitability of linear regression in this problem for your predictions? Can you expect any particular book to give you answers for these things, man? Books can teach you an algorithm. Books cannot teach you the reason for selection and suitability of that algorithm. So, filling your resume saying that I know all these machine learning algorithms is very much different from under what reasons you have selected that algorithm and for what suitability you preferred. Don't you think that it can come only by working with multiple different number of problems and involving yourself into the projects? Can we cook the stories in AI ML just because we have learned the technology? No way. Okay. Why people generally fail in AML project, like when they get into the interviews, is understand that you're explaining the subject, but the person sitting on the other side is only trying to understand why did you pick up that for your stability of requirement. How did you justify? How can you justify that algorithm is definitely the best for the criteria of that problem and the domain you have selected? So choosing the right machine learning algorithm depends on several different factors, but not one single factor. So teaching machine learning is not difficult, man. Making you understand the criterial reasons and requirements and the suitabilities of machine learning is a challenging. I hope you are sitting in the sessions for the second side of the process, not just the subjective side of the process. You're only looking for subjective side. My job is very easy, man. What is there? Every day I'll keep one algorithm in front of you, explain the mathematical formula behind that, tell you what library in Python can help you, and then just take some data, which is 10 or 15 records or 50 records, and then just work on that. We will get 75% accuracy. Then I'll say, like, you do multiple different number of iterations in epochs, you'll get the accuracy in a better way. But later on, you'll understand where you are really having the trouble. So what are the factors that will influence your choosing of the correct algorithm? The first thing is nature of the problem. So is the problem you are analyzing, catch up very carefully, is the problem what you are analyzing is falling under which particular type of category? Is it a classification problem? Is it a regression problem? Is it a clustering problem? And is it a reinforcement learning problem? Which one? It falls under what? So, giving the definition of classification, regression, clustering is very easy. Yes or no? But when a problem is given to you or your client is speaking with you, how you will try to put your problem into the criteria of the category? Is your problem is falling under only one single category there, or it could be a combination of the categories? Don't you think that this comes by doing more and more and more of problems rather than the programs? If you do the programs, you will get excellent in your language or the tool or technology. But machine learning algorithm is not the ability of the language, ability of the tool or technology. Machine learning is the area of getting the ability of understanding the problem and making the prediction. Catch up. Okay. The second thing is the type of data. Okay, choosing the right machine learning algorithm is also influenced by the type of the data. So once your problem is analyzed and understood under which category it fundamentally falls, then the type of data plays a very important role. Means the data in analysis, the data not in values, means which data influences your analysis. The data is categorical. Is it numerical? Is it time series? Is it text based? Or it is image? It is audio? It is video? So many things, or combination of all these things. Now, generally, when we say data identification for a programmer, it will be what, man? Tell me, for a programmer, generally data, type of data means what? Integer, float, string. Any of those things are influencing here? So imagine that you are sitting in my interview room and I'm asking you, can you tell me the nature of the problems you have been really experiencing in machine learning? Now imagine your answers are so banking, insurance, retail. In second minute, I'll understand that you are a fake experience. You can tell the domains, but how you should say? So I've been part of multiple different types of problems. Mostly my career was applied with an experience of working with regression level problems and classification level problems, applied in the domains of banking, insurance. But I also have the ability, and I am expecting to see that I gain my experience with respect to my next part of the career in clustering and reinforcement learning. Associate your domain with the area of your problem under which it falls. Am I clear? Learn how to answer your questions. Imagine I is asking you what is the type of data you have been using in your particular machine learning implementations. Imagine you're saying integer data, arrays, list, dictionaries. You're explaining the programming language data types. But you understand the difference of how you should answer now? Be clear. The third that influences with respect to the kind of right machine learning algorithm you have to pick up is the size and quality of the data. So when you take the problem, technically in your development environment, do you really work with huge size? Hello, no. But in practical implementation, once this project is released, what will be the size of the data? Not exactly by fixed values, but you should have clarity. This data will be in terabytes or petabytes, scaled on that percentage continuously. This kind of mindset you should develop. So large data sets may require what? Scalable algorithms. So whatever algorithm you are choosing, is that algorithm is scalable or non-scalable? Smaller data sets may need robust and noise resistant methods. Which algorithms will fall under this? A noise reduction and robust algorithm may not be scalable always, but a scalable algorithm will have definitely the features of the smaller data set advantages. So within your algorithm, whatever you have chosen which part of the algorithm works on scalability, which part of the algorithm will help you in building the robustness and noise resistant methods for the sake of the implementation. Don't you think that you need to take care of these things definitely when you're choosing the algorithm? Now, don't you think that 99% of the real-time machine learning implementations, they technically need scalable algorithms only? So, major part of the algorithms you're picking up should be scalable by nature. Next thing is, if you don't try to make your corresponding model robust and it doesn't has the intelligence of eliminating the noise. Noise means the unwanted state of patterns. Don't you think that you will go for unwanted accuracies? So data cleaning activity is one of the criteria. I mean, you cannot leave it. So the size and quality of the data that you are expecting, depending on that, you have to choose your algorithm once again. Then finally, when you totally keep your implementation to the reality of its execution, the computational resources. So if you are in the, as we have seen, technically you are in the decision making systems. I don't think you need a great computing resources, yes or no? Now, if you are really going with deep learning algorithms, you need more computational power integrated GPUs. Means when the problem statement comes from your client, don't you think that you need to have the clarity of telling the client very clearly what computational resources he should have? Imagine you are presenting your implementation, man. When you're presenting your implementation, you're giving him that suddenly after the whole project has been accepted and it has been done through the process, then technically you are trying to speak on the construct and composition of you need to have your GPUs and TPUs. Your client will run away because you did not tell him the budget cost when it comes to implementation. So can you put your algorithmic selection as straightforward as it does in computer sciences? No. Are you understanding why the industry is worried about the current resources, man? The industry is only worried about the current resources because with all that experience they have in programming, support, service, and everything, are they ready to change their mindset and the criterial requirements as demanded the machine learning? If you are a programmer, you may not be in a position to do anything great for my machine learning projects, man. If you're not changing your state of attitude, thinking, process approach. Therefore, remember very carefully, machine learning algorithms are generally classified based on the types of learning they facilitate. Means what kind of learning they facilitate, depending upon that, your algorithms are technically classified. Therefore, telling that I know this algorithm is very easy, man. But is that algorithm you are preferring is suitable to the problem to which you want to analyze or not is easily calculatable. You cannot fool. So when you take machine learning algorithms, what are the properties and characteristics I should consider? Two things. One, complexity and interpretability. Simple algorithms like linear regression are very easy to interpret, but may lack the complexity needed for high dimensional data. Means interpretation will be wonderful, but they will lack the area of application for complexity. Now you're keeping some project in your resume, and I personally feel out of my experience, it's a environment of complex state of implementation. But I find your algorithm you're mentioning is linear regression. Then I have some doubt. Either you are a starting level, means learning personality from the machine learning, Therefore, you do not know exactly what you want to apply. I'll excuse. But you showed experience and you're talking about linear regression for a complex problem, then definitely I'll get clarity out of your experience and exposure. The second thing is complex algorithms like neural networks are very powerful, but they will be very, very practically difficult to interpret. Means what is happening, why it is happening, why it is behaving like this. It's very difficult to interpret because they will work on multiple layers. Yes or no? In which layer the problem is arising, that interpretation can be complicated. So don't you think that when you take a problem, you should balance yourself between the complexity and interpretability every time? Then bias and variance trade-off. This is very, very important property, man. Machine learning algorithms need to balance the bias and variance. They should have the ability. Certain times your algorithm can go biased. Sometimes it can show a great lot of variance. Now, achieving 100% accuracy between these two is very difficult. That's where your ability of optimization lies. But you should at least know how to balance between these two. Therefore, high accuracy doesn't mean that your algorithm is going very perfect, and maybe somewhere it's getting biased. Now, your algorithm is not giving you exact accuracy doesn't mean that it is wrong. Maybe it is going with some trade-off on variance. I'll explain these things with implementation examples. Please wait, because each one we have to understand very carefully. Okay? Don't worry about that. Run very immediately. Bias and trade-off variance are very important terms to understand very practically. So remember, when you are implementing decision trees, means algorithms that are generally applied with decision trees, they can have very high level variance. But algorithms that are linear models, they can show high amount of bias. You have to definitely trade off between these two. Okay. So you take the algorithm definition from your computer sciences and you come and explain that in machine learning. Are you really thinking that you are justifying the interviewer's perspective? The simple question, man, what is exactly meant by algorithm as far as machine learning is concerned? Can you tell me? The way you speak on that will tell me you're a machine learning person or not. So I think there's a great lot of things we need to change intellectually and professionally if you want to come into machine learning. It's not technology is only a support. Do you agree with me? Can we say technology is everything in machine learning, AI and ML and DLs? No, 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 no. Okay. Now, just to try to put certain amount of frequency towards today's video, what we discussed once again, and try to make the construct of the concepts fit in your brain first of all, man. Okay. So that you all people being from the software side for so many number of years, I think we need to make some corrections to the corresponding definitions of computer sciences getting transitioned into machine learning side. Am I correct? If that's not happening, it creates confusion. I want to be on that now, such that with a fresh mind of thought process, I'll start with bias. Okay. First, we will try to understand bias. Okay. One term that is very, very important, not only to understand, but identify the influence and its level of participation to your machine learning process. Very important term, man. If you're just expecting the definition, I can make it very simple in one single statement. But understanding the bias makes you really understand your behavior of your algorithm in execution. Are you getting me? So with a fresh mind, we'll get into this particular term and its criterial features in next 24 hours. Narayana, let us wait. Okay. Let us not come to any conclusion. Just keep your mind free and it's like a white paper. I'll start writing bias on that. Okay. Let me do it. You don't give any kind of assumptions or assuming constructs. Okay. You don't worry about that. People may give definition on bias, but they cannot really understand the rule of bias very seriously. You leave it on my shoulders. Keep that energy and the positive frequency for next 24 hours, where early in the morning with this, we will start tomorrow. Clear? So our changed meeting link demos will go for another 2 days, man. Okay. Saturday and Sunday also we share. But from Monday, we are freezing the batch. From Monday, only those people who went for payments, they will be getting their meeting links. Okay. For people who have already paid, we will be getting your Python videos, man. Okay. Kismet classes will be there. Weekends, generally depending upon my availability, man. Okay. Because it's a morning session, most of the times, I think we can have it. Okay. If I'm not going on early travels. Okay. So people have already paid. We started sending them the Python videos, man. Okay. Just look into them. Satyendra is saying it is received. No, Abhinash. So your fee payments are confirmed. You'll be getting them into your mailboxes, your Google Drives. Ashirwad, if your payments are done, then technically you will receive them. Else, maybe today you will be getting them. Okay. Thank you very much, gentlemen. Once again with you tomorrow. Have a nice day. Take care of yourself. Have a great day.